I'm Mark Beasley, professor at the Poole College of Management and director of the Enterprise Risk Management Initiative, and I'm pleased to be here with two of my colleagues at NC State, Laurie Williams and Will Enck. Both are Goodnight Distinguished Professors in Computer Science in the College of Engineering. Laurie serves as the director of the Secure Software Supply Chain Center, S3C2, and Will serves as director of the Wolfpack Security and Privacy Research Laboratory, which we refer to as WHISPER, that we'll have them talk about in just a second. But thank you for being here with me.
Yeah, well, it's great to be here.
Laurie, can we just have each of you, we'll start with Laurie and then go to Will, talk about what your teaching and research is involving and give us a sense for the work you're doing.
Sure. So my research and teaching focuses on a general area of software security, which is the combination of software engineering and security, really focused on building secure projects from the beginning. Specifically within that, I focus on software supply chain security. And lots of people understand supply chain like toilet paper, supply chain, just getting parts from all over the world. Like a laptop, components come from all over the place, but there's actually a supply chain and security and software as well. And so a typical software product, only 20% of it is made within a company. 80% of it is likely to come from other places.
80% in a software package?
Yeah. And so an example of that is if an organization was going to have, an e-commerce website and they had to have a login screen, they don't start from scratch and create a login screen. They go get a login screen and they bring it into their software. And people do that all the time, is bringing in pre-manufactured, if you will, components from ecosystems and bring them into their software. And those are typically open source software, and definitely they can come from third party as well. But the problem is that they can be insecure. Either accidentally or maliciously, those components that come in can be insecure. And that's getting to be a bigger and bigger problem, as we'll talk about, I'm sure, a lot today. And we have an NSF-supported Secure Software Supply Chain Center, S3C2, as you mentioned, focused on the security of that so that organizations can get these components from the outside and feel safe and secure in their use.
You mentioned open source. That's a term we hear all the time. Can you just help a layperson? Tell me what that really means.
Sure. So open source means that people are creating assets like a login screen and saying, here, I made it, you take it. And then you can bring it into your project and use it. It's not proprietary, there's no money exchange. They can just take it and edit it as they want and use it in their projects.
Okay, that's great. Will, tell us about some of the work you're doing, and particularly the teaching and research that you're involved in.
Yeah, so I teach the undergrad and grad computer network security classes, and the research I do is similar to what Laurie does, but a little different. So I like to take computing systems, figure out how they tick, find security problems with them, and then fix those security problems.
Most people are pretty familiar with the importance of security when it comes to the technologies we use. We're used to having user IDs and passwords and dual-factor sign-ins and all the concerns about cyber breaches that we read about. So we have a sense for the vulnerability we face as it relates to software security. But we're probably a fair bit naive about the real risk and challenges that go with software, particularly from a security perspective. So based on the research you're doing, can you give us a sense for things that maybe a lot of people don't understand but might want to be thinking about? Will, see what you think about that.
Yeah, so we mentioned open source software earlier, and something that many people don't know is that nearly every application has some piece of open source software in it. And open source software is created from lots of different people, from companies to hobbyists who are spending nights and weekends working on something because it scratches an itch, they're interested in it. And we need to figure out ways of making sure that we help them make their software more secure. We can't give them more nights and weekends to work on these projects, so we need to figure out ways that we can help provide that. Another point is that no software is completely free of vulnerabilities. In some cases, we might say a piece of software is free of known vulnerabilities, but there might be vulnerabilities that are going to emerge in that. And so from that perspective, we need to think about how do we manage those risks that are in there with that, and know that this is a whole industry that it's messy. The data that we have on which versions are vulnerable versus not isn't always clear. And sometimes we trying to fight fires that aren't actually there. It's not actually exploitable. And the last, and this is the more surprising thing that's happened, is as we've made computing systems more secure, attackers are starting to move into the supply chain and maliciously inject vulnerabilities. And so we're starting to see this emerge. So you might be familiar with typo squatting for phishing, right? So you say, you look like it looks like it's Amazon.com, but that M is actually an R and an N. Looks very close. Well, this sort of thing happens for developers, and they might include the wrong library in a package. And then all of a sudden their developer workstation gets overtaken and now someone's into the development environment. Or they're using some library and it's maintained by someone on their nights and weekends and they're kind of tired and someone's helping them, maintain this project, and then they give them higher level access. And now all of a sudden something that wasn't malicious becomes malicious. And so these sorts of risks are growing as we're making overall systems more secure.
Okay, now I'm worried. Laurie, how about from your work?
Yeah, well, I mean, just continuing on what Will's talking about. So this open source, there are ecosystems like Maven, NPM, getting a little technical there. And so a developer, as Will talked about, will put something in there and then anyone can take it out. Mm-hmm. And one thing that people don't understand is that software is built in, like people hear, CI/CD pipeline. So you hear those terms, but the things that run the CI/CD pipeline are software themselves. And so that software can also have vulnerabilities. And there are ecosystems like that people can get things that aid in CI/CD pipeline, like GitHub Actions is one. So there's an ecosystem and people put these GitHub Actions in there and anyone can take them out. And now they are the target too. And people are putting vulnerabilities into the build software. Lots of people have heard of SolarWinds. Like that was an attack on the build infrastructure. And so all of the build infrastructure is an attack vector, just like the open source and third-party components. And so people don't quite understand that. I think another thing that would maybe surprise people is that there's all the hype about code generation tools and Copilot and tools like that, and people saying, now my developers are, 10x productivity. We're so much more productive, but the tools that generate that code can be vulnerable, and they can be vulnerable for one of two reasons. One is anything AI related is trained on data, and so those tools are trained on normal developer code, which can have vulnerabilities in it because developers don't understand quite how to write secure code. So just bringing in what developers write normally will cause the code that's generated to also be vulnerable. And then what is a concern is then attackers can intentionally put vulnerable code into the training data. So then the code is vulnerable. So when you say you're 10x more productive, well, you better check the security of that code that's being generated.
Mm-hmm. You both have touched on the open source, and we talked about that earlier. To what extent would an organization potentially have software that has been based off open source? Is that in every organization?
Yeah. But essentially 100%. I mean, I've seen like 99.7, so somebody does it.
So it's a high probability an organization is relying on software that is open source, has open source components or inputs to it that have exposure to some of the vulnerabilities you're talking about.
Right. And to some extent, it's foolish not to. There's a lot of source code that's out there that does very useful things, and re-implementing that, you're reinventing the wheel. Yeah. And so it's there, we should use it, but we need to understand how to then incorporate the risk into the products that we create.
So sort of that balancing that risk and return. There's a benefit to using it, but be aware of the risks that are going with that and think about how to manage that.
Yeah. Right. And then AI models, LLM, those types of models have their own ecosystem, and people put these trained models into an ecosystem, especially Hugging Face, that's the most popular. And those models can also have vulnerabilities and malicious data in them. And then you bring them into your package. And so it's something to be concerned about also.
In life, there's a lot of things that we just don't know, that we don't realize we don't know. And this is an area that I think a lot of us don't really understand the vulnerabilities that potentially we're exposed to. When you think about, organizations as they're trying to think through this issue, what would you say to help us understand better the importance of really thinking through these potential vulnerabilities for our organizations as you think about software security. So, Laurie, can you
So
give us your thoughts on that?
one thing is that it's inevitable. Like, there are vulnerabilities, you're going to have to react to them. And so having the processes and the roles in place to identify that there is a vulnerability that's going to affect your organization and a process to streamline responding to it. A good example of that was, I already mentioned SolarWinds, which ruined Christmas 2020 for a lot of IT people. And then the following year, Log4j was something that ruined a lot of people's holidays. And that was an unintentional vulnerability. So it was something a developer put in, not intentionally intended to cause harm, but when it was discovered, attackers jumped on it. When they jumped on it, companies that had a nice process, first of all, were aware. So one process is awareness of what's going on. And companies who were, number one, aware of it and had the processes to identify where in this corporation, where in this organization does Log4j exist in our software, they were able to identify and fix the problem in a matter of days, where companies that didn't have the processes in place were suffering for months. And so one really important thing is for people to understand it's inevitable and what are we going to do when it happens.
Just recognizing that reality and then have a plan in an event that does occur.
Right.
So, Will, how about from your perspective, what comes to mind?
Yeah, so expanding on what Laurie was talking about, I think it's really easy to forget just how pervasive software and computing systems are. Computers have gotten smaller, and there's software running in these small little devices, and they're connecting to wirelessly to something else. We don't see the wireless connections. We don't see the connections into cloud servers. And so they're everywhere, ingrained in finance, in transportation, in public utilities. It's not just our smartphones and our laptops that we're looking at. And so we need to recognize that there is this risk all around us in everything that we're doing. And so we need to care about what's going on with that. And so we may look often at security as a cost center. Right? How much are we spending on security this year? Oh, look, there's more vulnerabilities this year than last year. What are we doing in security? Why is we not getting better? But we need to take a step back and say, what if we didn't do the investments that we're doing? How much worse would it be? So we need to continue to invest in funding researchers to discover new problems and solve those problems, to funding within our own organizations, how do we manage and all the things that Laurie was just saying. So this comes together, not just with your company, but the whole community of companies that are dealing with software systems, which is essentially everything now.
It is everything. I mean, we can't do anything, it seems like, without touching that to some extent.
Right, and to go, follow on what Will said, attackers are only getting more and more aggressive. And so the fact that something really terrible hasn't happened is because of the investment that we have made. But we just have to keep making that same investment because attackers are investing and they're getting more and more aggressive.
So a lot of this, what I'm hearing is advice is just one, recognize the realities that there's a vulnerability that in a lot of cases you can't prevent as an organizational leader. But I need to be thinking through what is my plan in response if certain of these kinds of events start emerging that affect my organization, to have a little bit of a plan and strategy to navigate through the event. And from what you said, organizations that have those kind of plans tend to be better served than those that are just having to deal with it on the fly.
And that's a great point, because right now the overall community is moving from, it's not going to look bad that you were compromised. It's going to look bad if you were compromised and don't respond well to it, because we know that compromise is inevitable. It's going to come at some point. So having things in plan, how are we transparent with our other, when we're stakeholders and we have stakeholders in us, how do we make sure that we are reacting to it in a good way?
In a lot of things, ignorance is bliss. It's nice to not know these things so I don't worry about them because I don't know to worry about them. But given the work that you're both doing, you're so deeply informed on the topic, what sort of worries you the most as you think about the area of software security? Well, what's on your worry list or your watch list? Maybe I should say it that way.
Yeah, my biggest worry is there's some piece of software that we just rely on everywhere that has a backdoor in it. And so when I teach my security lectures in my class, I have this one lecture where I've got a picture of a web browser, 2 pictures of web browsers, one that says compromised, one's not compromised. And I ask the students, what's the difference between these 2 pictures? And they'll look at it and one will point out, well, that's there. It's like, no, that's the same. And eventually I say, it's the same picture. I just copied the image. And they look at me and it's like, why would you do that? Well, the answer is we can't really tell in most cases. Like, yes, there are indicators of compromise that you can find various systems to detect that, but they're looking at signatures of things we've identified before. And so this happened in March of 2024. We discovered that there was this compression library, XZ. Nobody had really heard about it before, but the way it was integrated in with Linux systems and with SSH, which is remote access to systems, made it really important in the supply chain. And somebody took multiple years to start contributing to that project, and so that the maintainer started to know them. Eventually got maintainer access to that project, and they slowly put in some backdoors. And they got it to the point where it was shipped in the experimental and sort of testing versions of some popular Linux distributions. And we were really lucky that this engineer at Microsoft was working on Postgres, this open source database. He said, why is this taking a couple hundred milliseconds longer in this case? And he started investigating and he found that there was this backdoor that was in that. And we were so lucky that we found that. What else is out there? And from this case, a lot of the techniques that we're looking at in software supply chain would not have detected that. And so some of my research now is like, how do we find this? How do we find these cases that we don't even know about that are out there?
Wow. Laurie, how about you? What's on your worry list?
Yeah, you started by saying ignorance is bliss. And so that's on my worry list. And, you know, at the leadership level, but especially at the software engineer level. And a lot of software engineers weren't brought up where security was taught. And now they're in the workforce and they're so focused on functionality that they're not caring about security. And even saying not caring is probably too much. They don't even know what's there. And so if you talk to an average developer and talk about software supply chain security, they're like, what's that? And like that login screen I talked about before. So they might say, oh, I saw this really cool login screen on the website of Joe somewhere in Russia, and it's so cool, I'm gonna bring it into my project. And don't understand the risk of that. That the fact that Joe, and you know, I should pick on Russia, but someone wanted to get the passwords, and so like in their cool login screen, they get the password sent back to them, you know, and they don't understand, you know, they trust, I guess, blindly trust what's in the supply chain, and really don't understand the risks. So that's something that definitely worries me. And the other is that companies often hire other software companies to develop components and don't demand security from them either. And so then they're actually paying money for software that's not secure, or they might put in their contract, like you need to have a secure software development lifecycle. And then the vendor says like, okay, if you say so, and doesn't actually do anything. And so, you know, my worry is we're just, you know, trust what's out there and then continue to generate more insecure software.
It sounds like it has a replication effect, you know, that these things can just expand exponentially once they get into the ecosystem.
Right.
You've both given us a lot to think about when you think about just the risk tied to software usage that we do all the time, every day. Can you give us a couple of thoughts on a couple of action items? If I'm leading an organization, what might I do in response to, now you've made me aware, what are some action items I could take back to my organization to think about this? Laurie, can you give us your thoughts on that?
Yeah, so I mean, we talked about ignorance is bliss. So let's undo the ignorance is bliss. We have one professor within our the SCI who did an interview study, and one of the things that came out was there's not enough security education. And so, you know, start an education program within an organization so that people become aware of what they're doing that's insecure, because security is everyone's job. There can't be like, oh, I'm going to develop my functionality and then security will find the vulnerabilities. It has to be built in from the beginning. So the only way that can happen is if people are educated. So that's definitely an important action. And the other is to within an organization, AI is so cool. Everyone wants to get AI in their products, but there are a lot of security risks. Security risks in the generation, as I mentioned, security risks in like going to Hugging Face, getting this cool model and bringing it in. There's security risks with that. And then even just the use of, if you go to ChatGPT and put your code in, now you contributed it to the world. And so there's not necessarily an awareness within the average person working in a company of the risks of the tools themselves. There are vulnerabilities, prompt injection and things like that of the use of the tools. And so make sure that the people are using them smartly. So both of those are kind of education related.
Yeah, just awareness, as you said.
Awareness.
Because a lot of this, it sounds like, it's hard for me to prevent a lot of it as a leader of XYZ company.
Right.
But my awareness is a big prevention strategy in
Right.
some ways just to help reduce that. Will, how about you? What are some of the action items that come to mind?
Yeah, so we've talked a bit about open source software today and how it's such a great resource to build upon. And many organizations look at this free implementation that I got. And there's this saying that you need to think about open source software as free as in puppy, not free as in beer, because there's this maintenance cost that goes with it. And it's not just making sure you're getting the security patches from that, but making sure that the ecosystems of the software that we depend on is being maintained. And sometimes that's a financial contributions, but other times that's allowing our employees and giving them some time of their employment to go and help contribute back to those projects. And so encouraging them to do that so that the things that you depend on are there and you have those relationships with those projects. And if all companies are doing this, the overall ecosystem gets better.
Everybody sort of working towards solving the challenge there. Organizations are very frequently looking to purchase or get access to software packages as they're looking at those vendors. What are some of the things that they could we could be thinking about as we evaluate software A versus B from a lot of the security concerns that we've talked about today? What would be some tips of things that they should think about doing?
Yeah, I'd say don't look at that tool in a vacuum. Think about how it would work in your organization. Talk to your software engineers, your security engineers, and figure out how would that work with the software and the processes that you already have. We had a paper recently where we interviewed users of these source composition analysis tools. So these are tools that have become popular to figure out, well, what external components are using these open source libraries? What vulnerabilities do they have? How can we fix these? And a couple takeaways we got that. One was there's no one tool that's perfect for all software languages, right? So customize, what are you actually using? And another interesting comment I heard from one participant was that in their organization, different groups were using different tools. So software engineers were using one, security engineers were another, lawyers were using another tool. And there was a lot of overhead just figuring out, well, what is the problem that's here? And so thinking about how does this work in your organization, other parts of security. So you might want to bring in, well, I'm going to take this application, I'm going to deploy it in this environment. We have these other security tools that are going to monitor risks there. Can these tools work with one another? And so looking at overall for your organization, what fits us best, not just what I've seen an ad on or I went to some trade show and advertised as being the top tool.
The work that you're doing is incredibly fascinating. It's very relevant. The research that you're involved in is so important to all of us. So thank you for the work you're doing, and thank you for taking the time just to speak with us today, just to help us better understand the realities of that. And I think hopefully you've moved us a little bit down the awareness path to make us more aware of the issues and challenges we need to be thinking about. So thank you for being here.
Oh, thank you for inviting us. This has been great.
Yeah, our pleasure. Thank you.